children, take out your geography book. Today's topic is composition of the atmosphere. Introduction. Our world, Earth, is the only living planet that supports life on its surface. They live on the solid surface built upon the favorable condition and composition of atmosphere and utilize sea as source of food and intercommunication. There is a continuous flux of energy and matter between the sea surface and lowermost layer of the atmosphere to provide the condition more suitable for existence of life like water cycle, heat cycle and balance between the two. Thus, Earth's environment is a shallow but highly complex zone in which the atmosphere condition exerts control over the land surface, while at the same time the surface of the land exerts an influence upon the properties of surrounding atmosphere. A study of the atmosphere, oceans and land requires continual application of the principle relating to three basic states of matter: gaseous state, liquid state and solid state. The three realms of Earth, the atmosphere, hydrosphere and lithosphere, contains the three basic states of matter. Atmosphere largely composed of gaseous state, also contains varying amount of liquid and solid state in the form of water vapor and dust. An observation concerning states of matter is that a change of state is possible and occurs frequently in the world of nature. For example, the most important and widespread change is that of water from water vapor to liquid water and vice versa, and from liquidization to ice and vice versa. These changes of state require either an input of heat energy or the disposal of heat energy, depending on the nature of change. Most of these changes take place in the atmosphere surrounding the Earth. Atmosphere is a relatively thin layer containing a number of gases, dust and vapor enveloping the Earth as far as 9,600 km above the Earth's surface. The envelope of air surrounding the Earth is called atmosphere. It is a colorless, stateless and odorless substance and is mobile, elastic and compressible. The most interesting fact about air is that we do not feel its presence unless there is horizontal motion in it. Air in horizontal motion is known as wind. Although air is not as dense as land or water, it has weight. The pressure it exerts on the surface is called the atmospheric pressure. Composition of atmosphere. The Earth's atmosphere consists of a mixture of various gases surrounding the Earth up to approximately 10,000 km, approaching the diameter of Earth itself. It is an envelope of gases encompassing the Earth held by gravity. Two main gases, nitrogen and oxygen, make up about 99% of clean dry air. The remaining gases are almost inert and constitute about 1% of atmosphere. On the basis of composition of gases, the atmosphere may be divided into heterosphere and homosphere. Heterosphere, thermosphere. The heterosphere begins at around 80 km altitude and extends outward some 10,000 km. However, for all practical purposes, most of the meteorologists consider the topmost layer of the atmosphere at around 480 km above. 480 km, the atmosphere is rarefied and is called exosphere, which means outer sphere. Exosphere contains light gases like hydrogen and helium weakly bound by gravity. In addition to its distinctive layer gases composition, the atmosphere has a thermal region and within its functional layer. Ionosphere, thermosphere or ionosphere extends from 80 to 480 km in altitude. Both the thermosphere and ionosphere functions to filter harmful wavelength of solar radiation, protecting the Earth's surface. Ionosphere is composed of atoms that acquire electrical charges when they absorb cosmic rays and gamma rays, etc. These charged atoms are called ions, giving ionospheres its name. Homosphere. The chemical composition of the atmosphere at an altitude of about 80 km from the surface of the Earth is highly uniform throughout in terms of the proportion of its component gases. This lower layer of atmosphere is called homosphere. Even though the atmosphere rapidly increases in density with increasing altitude, the blend of gases is uniform throughout the homosphere. The only exception is the concentration of ozone in the ozone layer from 19 to 50 km and the variation in water vapor and pollutants in the lower portion of the atmosphere near the Earth's surface. Pure dry air of homosphere consists largely of nitrogen and oxygen. The remaining 1% of the air consists of mostly argon and carbon dioxide. The major gases and their importance to life. Nitrogen. Nitrogen does not easily enter into the chemical union with other substances and can be thought of primarily a neutral filling substance. Very small amount of energy is absorbed by soil bacteria and used by plant. Oxygen. Oxygen is highly chemically and combines readily with other elements in the process of oxidation. Combustion of fuels represents a rapid form of oxidation, whereas weathering of rocks represents slow forms of oxidation. Carbon dioxide. Although carbon dioxide constitutes only 0.33% of the total composition of atmosphere, it is important in all atmospheric processes because of its ability to absorb heat. It allows the lower atmosphere to be warmed by heat radiation coming from the sun as well as from the earth's surface. As mentioned earlier, green plants in the process of photosynthesis utilize carbon dioxide from the atmosphere, converting it with water into solid hydrocarbons, argon. A very small percentage of argon is present. Being inert, it is not much used in natural processes. It is extracted from the atmosphere for commercial and industrial uses. The remaining gases of Homosphere include neon, helium, hydrogen, methane, krypton, xenon and nitrous oxide, which altogether constitute only 0.003% by volume. All the component gases of Homosphere are perfectly diffused among one another so as to give the pure dry air a definite set of physical properties. And with this, I am ending my today's class. Goodbye.